Okay, so we're in the probability chapter, and the notes for next class are about what's called expected value. Now, if you took a look at the notes already, there's a little bit of discussion of using what's called a spinner as a way to conduct a random experiment. So it's similar to flipping a coin in some instances. But I thought that I would sort of take a couple of minutes to briefly go over what that really means, since we're going to be using it as an example, or as a way to generate examples in the guided notes for the expected value material. And it also is a good way to reinforce the law of large numbers. So I am in the Moodle section for expected value, and you should see that there's a link here called the Adjustable Spinner Applet. So I'm going to click on that, and it should take me to the Interactivate website that has this spinner applet that you can adjust to your liking. So I just want to use two sections. So I'm going to decrease the number of sectors to 2. And for this experiment, I actually want to make the spinner have a 55% chance of landing on blue, and that means a 45% chance of landing on pink. So if I click Update, after typing in the percentages I want, you'll see that the blue area now is a little bit bigger than the pink area. A couple of other things to notice. Over here we have the theoretical probability of spinning and having the needle land on blue. That's 55%, and then the theoretical probability of landing on pink would be 45%, because there's 55% of the spinner is blue and 45% of it is pink. We could also list these as 0.55 or 0.45 if we were using decimals. So the way this works, if we go ahead, I'm going to leave the number of spins at 1 for now. But I'm going to click on Spin down here on the bottom left corner, and you'll see the needle move. And for that first spin, we landed on pink, and it kept track of that first spin by keeping track of the experimental probability. We had one spin, it landed on pink one time, so that's 100%, 0% blue so far. Now you might recall that that is the same as the relative frequency. Right? So remember, if we're in an unfamiliar situation, you have to try it, and then the way you estimate probability from that situation is to calculate the relative frequency, the number of times something happened divided by the number of times you tried the experiment. Now we can spin again. We got pink again. One more time. We got a blue. One more time. Pink again. So out of the first 4 spins, 25% relative frequency for blue and 75% for pink. Now the law of large numbers says that if we spin enough times, these experimental probabilities should look a lot like the theoretical probabilities. And there's an easy way to do this. I'm going to wipe out the results, and what we need is to be able to spin a lot of times. And we want to do it without spending hours clicking spin. So the way we do this is just to enter 1,000 for the number of spins we want to execute, and then the applet simulates 1,000 spins and keeps track of the results. So I'm going to click spin, and now notice what happened in the count. We got 568 blues, 432 pinks, and so 568 divided by 1,000 is 56.8% for the relative frequency, 43.2% for pink. And notice how much closer we are now to the theoretical probabilities. Right? We're within, 1.8% of the actual theoretical probability. So if we were to continue spinning, so there's another 1,000 spins. Now we're within 1.55%. Another 1,000 spins. Another 1,000 spins. Look how close we're getting to the theoretical probability. We're within about 0.3%, 0.28% right now. And now we're within 0.05%. So after 6,000 spins, right, we're virtually indistinguishable from the theoretical probability when we calculate the relative frequency. So in the notes for the expected value section, when I say we're going to, we have a random spinner with a given probability and we spin 1,000 times, this is kind of what I have in mind, right? I'm doing this simulation where if we spin enough times, the experimental probability will be really close to the theoretical probability. That's the law of large numbers, once again, and we will take advantage of that as we develop a formula for what we call the expected value for a random situation. Now, expected value is really, really important, not just in this particular class, but in the world in general. There's a lot of sort of common everyday things that are based on expected value, including casino games and things like warranties and insurance policies. All right, so that's all I wanted to do for this short section, is to show what this adjustable spinner is and how we can use it to kind of simulate a lot of random trials